Morning viewer, welcome to our active English version. Here's a breaking news. An influential hypothesis in neuroscience is that the brain may operate near criticality, a transition zone between subcritical dynamics associated with excessive inhibition and supercritical dynamics associated with excessive excitability. In preclinical and computational studies, activity near this region has been linked to different information processing and adaptive responsiveness to input. Empirical evidence connecting such criticality sensitive dynamics to cognition in typically developing children and adolescents, however, has been limited. We therefore asked whether these dynamics relate to IQ. Our findings are published in the Journal of Neuroscience. A key mechanism underlying criticality in biological system is the balance between neural excitation and inhibition. So, shift in this balance can push neural systems toward overly quiescent or overly excitable dynamics, whereas more balanced regimes are more consistent with a near critical activity. Like a car, too much gas and too little brake makes the systems hard to control, while too much brake and too little gas keeps it from moving well. The brain may also function best between extremes. We used two EEG derived measures reflecting different features of brain activity. The first measure was the functional excitation inhibition ratio, that is called FE-1I, and this measure comes from computational work showing that the relationship between oscillatory amplitude and long range temporal signal structure changes as neural systems move between subcritical, near critical, and supercritical regions. In that framework, FEI values closer to 1 are more consistent with a near critical region. The second measure was the I-F, a periodic exponent. Unlike FE-I, this measure is not based on oscillatory activity but on the background shape of the EEG power spectrum. A flatter a periodic slope means faster activity remains more present relative to slower activity. Earlier computational work suggested that the exponent may also be sensitive to excitations, inhibitions related dynamics, and that a flatter, lower aperiodic exponent could reflect a higher EI. However, there is no established critical I-F value. Then the exclusive report.